Okay, so maybe we will have some examples in order to we will better understand how to solve non-elementary functions, okay, using the replacement of its equivalent power series. Okay, so we all know that there are power series, okay, so for equivalent power series for some trigonometric and hyperbolic functions, as well as um, exponential functions and logarithmic functions. Okay, so these are not the only one. So but we will discuss more on uh, effectively use the knowledge of our knowledge of power series in order to solve some complex problems, integration problems. Okay, so let us say we have this problem. Okay. So dy over dx is equivalent to hyperbolic cosine of x squared. So how do we solve this one? So it's not, okay, so if it's only hyperbolic cosine of x, so we can solve the problem, but it's not. So therefore, we need to replace this, okay, by its equivalent power series. Okay, so it will become this, okay, for one more manipulation. So if we integrate this one, we cannot integrate that one through elementary method. Okay, so it will become, we need to replace it by its equivalent power series, which is 1 plus n is equal to 0 to the infinity. So please take note that this is x squared, so therefore x to the power of 2n, so it will become x to the 4n over 2n factorial, okay, dx. Okay, so therefore your answer will be y equals to x plus infinite sum from n is equal to 0 to infinity, x to the 4n plus 1 over 2n factorial over 4n plus 1 plus c. So therefore, this will be your answer. Okay? So your answer will be in terms of power series also. Okay, so that's one of our examples. Okay, so let us say we have another problem. So this time maybe let's involve, okay, so let's involve it with exponential functions. So let us say we have a problem such as this, exponential problem. E to the power of square root of x. So how do we solve this one? Okay. So by inspection, we could not solve it one direct. You cannot solve it directly using ordinary knowledge of differential equation, of integration. Okay, so whether you memorize the entire table of integration table in your in your book, so there is nothing listed like here. Okay, usually. So what we do, we convert it. So we know that e to the power of x is equivalent to um, the infinite sum n to the 0 to infinity x to the power of n to the power of n factorial. So therefore, e to the power of square root of x will be equivalent to n to the 0 factorial x to the power of, okay, since this is square root of x, so you will replace it by square root of x here. So x okay, so the square root of x will replace x here. Okay, so this will be actually equivalent to the infinite sum into the 0, infinity, okay, x to the power of 1 half of n over n factorial. Okay, so from that time, so we can already integrate. So therefore, it will become y is equivalent to the integral of this one. Okay, this case. So n to the 0 to infinity. So this x to the 1 half n over n factorial. So therefore, it will become if you integrate this one, so it will become x to the power of 1 half n plus 1 over n factorial over 1 half of n plus 1 plus c. So therefore, this will be your answer. Okay? So this will be your answer for this problem. Okay? So see that we have already solved the problem using power series. Okay? So maybe let's have another example. Okay? So let us say this problem. Okay. So let us say we have a problem. Okay, so let us make it distinct. So let us say this is your differential equation. So how do we solve this one? We cannot solve this one directly because it is sine of x cubed. So what we do again, so we apply so we convert it into power series. So we know that sine x is equivalent to the infinite sum n to the 0 to infinity negative 1 to the n x to the power of 2n plus 1 over 2n plus 1 factorial. Okay, so this is sine of x. So therefore, sine over x cubed. So we replace x by x cubed, so it is equivalent to n to the 0, infinity. Okay, so negative 1 to the power of n x. Okay, replace x by x cubed, so it will become x to the power of 3 times 2n plus 1 over 2n plus 1 factorial. Okay. So therefore, it will become (6n to the power of 6n plus 3 over 2n plus 1 factorial. Okay. So that will be your equivalent of sine x cubed. So it's not yet finished. So we replace now. So we replace, instead of sine x cubed, we replace this. Okay, we substitute rather. Okay, yeah. So we have, so therefore, we integrate dy equals sine, integral of sine x cubed dx. Okay, so it will become y is equal to replace. Okay, so integral of n to the 0, infinity, negative 1 to the n, x to the 6n plus 3 over 2n plus 1 factorial. Okay. So therefore, it will become n to the 0, infinity, negative 1 to the n, then x to the 6n plus 3 plus 1 over 2n plus 1 factorial. Okay, so it will become 6n plus 4 rather. So we will make it shorter. So 6n plus 4. Okay, so for plus c. So this is your answer already. So this is the solution of that. Okay? In terms of power series. So I hope you understand now. Okay. When we substitute power series in order to solve some integration problems and differential equation problems.